Hello, this is Mr. Anderson for Kellogg Community College, and this is our 5th video to talk about the Unit 1 review for the test. And what I have for you here is a little walkthrough of conditional probability. Now, the book definition of the probability of B choosing A is choosing, and again I'm going to write the formula here, that I want to know what are the chances of pulling an A and B out of the group of A. So I want to make sure that you understand the problem in its context, so I'm going to just quickly dive in here. And the ordering of the B and the A is important because we want, in our numerator of our fraction, to find our probability here of male pediatricians, or the A and B, out of the group of pediatricians, or A. So this is like saying I want a pediatrician who is male out of the group of pediatricians. So we can see easily from the chart that our group of male pediatricians, or the numerator of our fraction, is going to be this 33,020. And the group of pediatricians would be the sum of these two numbers here, which is 66,371. If we do our division, we get an answer of 49.8%. And again, according to the problem setup, we were looking for the chance of getting a male pediatrician out of the group of pediatricians. And that flows into this example, and I want you to think about it here. What would our numerator be? It would be the group of, and our numerator has two different things to it, so it would be the group of pathologist female or female pathologists, and that would be easily found with the number over here, out of the group of what? And in this case it would be the group of females. So we would have the numerator easily spottable out of the group of females, and the reason why it's out of the group of females is because that's our A according to the setup of the problem, and we would add up these numbers to get a total. And the total number, if we added up all of these three females in their fields, we would get an answer of 51,247. So 51,247. If we divide these two, we get an answer of 10.9%. So that's conditional probability, definitely a formula to memorize of B and A in that order. The A will always be your denominator, and this is in the book too if you wish to dive deeper into its reasoning there. But now we're going to talk about factorial, permutation, and combination. Now these formulas here are easily findable on your calculator, but I want to show you on the graphing calculator where to find these. So if we're using factorial, and again I'm going to write this down too, is that you would use factorial when you would want all items in a specific order. To do this on the calculator, we would type in the 7 first, and then the factorial button would be clicking math and then choosing probability, or prob on some of the newer calculators, and then moving down to object or item number 4, and that would give you your 7 factorial, which is 5,040. So this is saying, in this problem here, there are 5,040 ways to choose 7 items in order. So if you had 7 soft drinks up on a shelf, to rank them from first to last would be quite a feat, because there would be 5,040 ways to do this. Your first choice is only one of those ways to do it. So 4 factorial, let's go and investigate that. 4 factorial is 24. Now what I'm going to do is freeze the screen for a moment here and show you how the formula actually works. The n factorial, or this symbol, means is that we're going to start with the number and multiply that by 1 fewer than that, and multiply that number by 1 fewer than that, until we get down to the whole number 1. So 4 factorial, which happened to be 24, is the same as going 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24, times 1 is 24. There you go. And there's your number, 24. So 1 factorial is going to be 1 times, well, just nothing else since we're already at 1, so there's only one way to choose one item. Now, the problem I'm not showing you here is, because it's blocked by the calculator, is 0 factorial. Now, by definition, 0 factorial, and don't shout out the answer if you don't know it, because most people say it's 0, but 0 factorial, in fact, is 1. And 0 factorial is 1 is that there is only one way to get no items. And, yeah, that's nothing, right? All right, so then we're going to go down to permutation. Now, permutation is when we want some of the items in a specific order. This isn't the lottery. This is actually a locker problem. Now, it's funny that in the world we have called lockers combinations, but actually combinations isn't the right word. If you look up permutation in the dictionary, permutation actually means taking things in order. So if you ever had to do a locker permutation, this is actually what you're doing. We've been calling them locker combinations, but that's wrong. It's really locker permutations, because we have in this problem 5 items. Click Math, click to Probability, and choose NPR. We have 5 items, and we want to choose them, a smaller subset of them in order, and get an answer. And so there are 60 ways to choose 3 items from a group of 5 in order. And we can repeat this process for part B, which is 7, and then the 7 would be Math, and then Probability, choosing your NPR, and then choosing 4, and then getting your answer. There's 840 ways to choose 4 items from a group of 7 in order. Now, you're doing this and you're getting the answers and feeling, wow, this is really great. I'm just going to go, do this and type in 2 and get an answer of 30. Yeah, but you're still not quite getting what this actually means. So I'm going to bring this over to the side here and freeze the screen. And I'm going to do some writing, because I'm actually using the calculator and not actually doing the formula, which is when I have NPR, which is the number of items in my set and the number I'm choosing. It's really this fraction of the n factorial divided by the n minus r factorial. This is the formula of this. And so what I want to show you in this last example, since we have 30 over here, I want to show you how that's done. If you were to do this by hand, to pick out of 6 items, 2 of them in a specific order, I would have to choose, let's see here, I would start off with my numerator, which is going to be my n, and my n is going to be 6 factorial. And my denominator is going to be 6 minus 2 factorial, or the same thing as 6 factorial over 4 factorial. Now, how would you solve a problem like this? You'd solve a problem like this by writing out the factorials. You go 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, you'd type out 4 times 3 times 2 times 1, because that's 6 factorial and 4 factorial. Now, due to simplification, 4 divided by 4 is 1, 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 is 1. So we have 30 different ways to do that problem. 30 different ways to pick 2 items in a specific order out of a group of 6. And that would mean that you'd have your 6 items to choose from, then 5 items to choose from, and the rest are duplications, because you're not choosing your full set. You're not going all the way down, to picking all 6 items. Now, what we're going to do is the last item, which is combination. Now, combination has the same beautiful shortcut on the calculator. By using your probability functions, you can go to here, to NCR, click on this, bloop. There are 10 ways to pick 3 items in any order. Now, I want to highlight this again. Permutation is in order. Combination is without order. So it's a lot easier to pick items without order, because you have, the same way. If you consider them, first through third and third through first is actually considered the same way, because the order doesn't matter. This is like volunteers. Like, I need 3 volunteers out of you 5, and I don't care the order. And, the first three people, chosen is the same as if they all volunteered in a different order. And so we got C, and we got NCR, bloop, and we got 4. So 35 for that problem. And this is the problem I actually want to do. I'll freeze the screen and show you the actual formula to this. The formula to this problem is the combination of NCR is n factorial divided by n minus r factorial. And you're probably looking at this going like, well, isn't this the same thing as the one up above it? But it isn't, because we're also going to multiply by r factorial, because that will get rid of the duplications that occur when we have a problem where the first three people join. It doesn't matter the order. So this last little piece here, by dividing that from the original number here, will get to a spot where the 7 factorial is going to get to a spot where we are going to have some duplication in the problem. Now, I've got 7 factorial and 3 factorial, 4 factorial. Let's go and figure out how we got 35, because the numerator is 7 times 6 times 5 times 4 times 3 times 2 times 1. Our denominator, 3 factorial, is 3 times 2 times 1. And then 4 factorial is 4 times 3 times 2 times 1. Now, the 4, 3, 2, 1 simplifies with those, and 6 is divided with those, because 6 divided by 3, 3 times 2 is 6, and the 6 divided by 6 is 1. So 7 times 5 divided by 1 is 35. So that's how I get that. There are 35 ways, and you'll note that this was 840, which means that picking 4 items in order out of 7 is a lot. But picking 4 items out of 7 without any order, it's significantly less, because of the overlap that can occur when you pick 4 items. Now, this last answer here is going to be, if you type that into the calculator, 1. And it's 1 because, not 1, it's 10. Sorry about that. It's 10 because if you're choosing 9 items out of a group of 10, there are 10 ways you can leave 1 item behind. And so that's the answer to this problem. It's also one example I did in class is this is going to be 1, because the only way I can choose 10 items from a group of 10 without order is 1, and that's just by grabbing everything and putting it into the shopping cart on maybe your supermarket dash sweepstakes game. Now, the last thing I have to leave you with is that this section of the test is going to be very, very special, from the idea that we will have a part of it where you have to tell me if a problem is either factorial, permutation, or combination. Now, the way to do that is to identify if the problem is asking for some of the items or all of the items. Now, if you're looking for all of the items, we're definitely dealing with factorial, because this is all the items in order. So an example of this would be how many ways, like if I said this in a story problem, how many ways can you pick your top 10 bands out of this group of 10? Well, I'm asking for all the items in order, so this is clearly a factorial problem. On the test, you wouldn't have to solve that problem due to time, but you would have to identify what kind of problem it is. Because once you identify the kind of problem, then solving it's really pretty simple. Now, getting down to permutations, these are both the permutations and combinations. These are some items for both of these. Now, I've made it really apparent that if I'm talking about a locker problem in middle school or high school, then we're talking about a locker permutation, because we want some items in order. And here I want some items without order. This would be more your lottery ticket. You do on the Powerball and Megaball power lottos, you have to pick one number for your Powerball or Megaball or whatever it's called. But for the most part, most lotteries have you just, like some of the classic lottos, you just have to pick the numbers without order. You just fill out your little betting slip, and the ping pong balls come out, and whatever order they come in is fine. So these have to deal with more like password-specific things, where the order of numbers make a difference. This is probably more like just dealing with volunteers. Like, hey, I need 3 people to help me out of you 5 people with something, and that's a combination. That would be like the order doesn't matter. But here, where if I have like how many ways, and that really kind of is a tip-off there if you're dealing with, when I say how many ways, that's a really good indicator that we could be talking about a permutation, because if I'm saying how many ways can we rank these 3 bands out of 10, then bam, we're talking about a permutation. And notice up here I use the band, analogy, but that was 10 bands out of 10. So you will have to know the differences between these 3. And if you were feeling like, oh man, we didn't do enough of these by hand, just wait. The next chapter, when we start to do binomial distribution by hand, we'll be doing enough of these. Oh, believe me. But thank you for watching the final video, and good luck studying. And I appreciate the time that you're working with this class, and thanks for watching.